Okay, so this is the test that I'm releasing in 2021. It's a previous year's test. Let's look at question one. It says, solve the system of equations. You may use either substitution, elimination, or the equal values method. Failure to show your work will result in no points. So let's show our work here, okay? So this first problem is very, very close to being a great setup for elimination. I think the only thing that I would want to do is take this second equation and multiply it through by the number negative 2. So if I did that, this second equation would become negative 4x plus 6y, and that would equal negative 12. So did I do that right? Let's see. Negative 2 times 2x is negative 4x, negative 2 times, yeah, and then, yeah, that's correct. So let me write the first equation down again. So the first equation was 4x plus 11y equals 80. And when I take these equal things, right, from this equation, and I add these equal things to the respective sides, I end up getting 11 and 6 is 17y is the same as 80 minus 12, or negative 12 plus 80, and I get that that is 68. So if I divide both sides by 68, I get that y is the number 4. Now that I know y is 4, I need to figure out what x is, and I guess I'll just use that top equation. So I'm going to write 4 times x plus 11 times, playing the part of y, is 4, because I just found y was 4 right here. And then that's going to equal 80. So 4x plus 44 equals 80, not 8. 80. 80 minus 44 is 36. So 4x equals 36, and x is 9. X is 9. Right, so we know both x and y, so we have our solution, right? Our solution is the point where x is 9 and y is the number 4. Certainly worth it for you, especially if you're sitting in the class and you're ready to go on to the next problem, to as quickly and as efficiently as you can to test your solution. So if I was to bring up the calculator here, I know that 4 times the x plus 11y should be equal to 80, so I'm going to go 4 times the x I found was 9 plus 4 times 11, or 11 times, yeah, there we go, should be 80. Uh-oh, I typed the wrong, I got a T there, that's crazy. Let me do that again. 9, not 9, or 4 times, let me do this right. 4 times 9, 4 times x, right, 4 times 9, plus, oh geez, now my calculator's gotten all out of control here. Plus 11 times 4. By the way, this is not quick, this is not efficient. And 4 times 9 plus 11 times 4. Are you kidding? Can you not do anything right, Mr. Roberts? This is supposed to be multiplication. There we go. Oh, at last. Okay, 4x plus 11y is indeed 80. Now let's see if this is better. 2x, so 2 times 9 minus 3 times y, 3 times 4. This should equal 6, and it does. All right, so we have our solution. It checks quite happily, if not slowly, and we can move on to the next problem. Oh, and the next problem, would you look at that? That's so sweet. I'm like, okay, I could do substitution, right? But it's going to give me a fraction, which makes me always cranky. So maybe I don't want to do substitution. I'm going to do substitution anyway. Well, I could go equal values method. Maybe I'll do that. Let's get y alone in the second equation. So I'm going to isolate the y in the second equation. So to do that, I'm going to subtract x from both sides. So I get negative 2y is, I'll just write negative x, no, not negative 4, negative x, and then plus the 14. Okay. And then I'm going to divide everything in this equation by negative 2. Oh, just a moment. Someone joined the class. Okay, I think I said I'm dividing both sides by negative 2. So this is going to become a y. And on the other side, when I divide that by negative 2, it's a negative 1x divided by negative 2 is going to give me a positive 1/2 x. And then minus the number 7. So if I look, I now have two ways of writing y, right? One of the ways is this, whoops, I meant to change the color. This is equivalent to y, 1/3, negative 1/3 x minus this. This is equivalent to y. And then also this is equivalent to y. So certainly in the context of this problem, y is equal to itself. So I'm just going to go ahead and say, hey, since it's the case that y will equal y, I could take this top form of y, which is negative 1/3 x minus 2, and that's going to equal the other form of y, which is 1/2 x minus 7. I'm going to multiply both sides of this by 6. If I hit every single term with a factor of 6, it'll eliminate all the fractions. So this needs a 6, right? This needs to be multiplied by 6. This term needs a 6, and this term needs a 6. So when I distribute that across the entire equation, I end up getting 6 times negative 1/3 is going to be a negative 2. So I've got negative 2x minus 12 equals 6 times 1/2 is going to be a 3x. And then 6 times negative 7 is going to be negative 42. I guess I'm going to add 2x to both sides. So I have negative 12 equals 5x minus 42. Okay. And then I'm going to add 42 to both sides. So I've got a negative 12 over on the left-hand side. I'm going to add 42 to that. When I do that, I get over here, this is 30 is 5x. Therefore, 30 divided by 5 is 6. So I know my x value is the number 6, I think. Now to figure out what y is, that top equation tells me what y is, right? Y according to the top equation that I boxed in purple is equal to the opposite of 1/3 times 6 minus 2. Negative 1/3 times 6 is going to be it's going to be negative 2 minus 2. Looks like negative 4. So y is negative 4. And without checking it fully in both, I'm going to just plug the same value into the other equation and see what I get. When I plug 6 into this second equation that I boxed in green, right, when I plug 6 into that, it's going to give me 1/2 times 6 minus 7, which is 3 minus 7, which is definitely negative 4. So I'm confident that this is our solution. X is the number 6, and y is negative 4. And if you find you have, extra time on a test, you can certainly come back and plug those two values into both of the original equations and make sure that you do get the same thing on both sides. All right, so that's question number 1. Solve a system of equations. We use the equal values method. I got y alone in the second one, and then the top one I use the elimination method.